We'll now talk about modular design. So one powerful tool for managing complexity is to design your system so that the programmer is only thinking about some of the complexity at once. By using helper methods and helper classes, you can hide the complexity, right? And so again, this is essentially saying we want to abstract away the complexity. There might be, some other parts of the code, but if the programmer doesn't need to see the inside or the guts of how that works, let's hide it from them. This is going to bring us a modular design. And so in an ideal world, each system could be broken down into modules where every module is totally independent. Here, a module is an informal term referring to a class, a package, or other unit of code. It's not possible in the real world, for modules to be entirely independent because code from each module has to call other modules. But as much as we can, we want to have these independent modules that will hide the complexity, so you're only ever really focusing or working on one or a couple. And so in modular design, our goal is to minimize dependencies between modules. We can sort of talk about this through the lens of interface versus implementation. As we've seen, there's an important distinction between interface and implementation, right? A deck is an interface, but the linked list deck, array deck, tree deck are all implementations. Sorry, I'm letting my dog out. And so those are specific implementations of the deck interface. And so Ousterhout says the best modules are those whose interfaces are much simpler than their implementation. Why is this? We can take a moment, think about that. The simple interface minimizes the complexity the module can cause elsewhere. If you only have a getNext method, that's all someone can do. And so if your interface is very cleanly defined, anyone who's calling your interface or using it also by nature has to, sort of be simple and use this simple code. And so it helps simplify elsewhere. You're having a great effect on everyone who calls you by being simple. If a module's interface is simple, we can change an implementation of that module without affecting the interface, right? And so this is a really important part of, I would say, interface design in general, is just that if you have the interface and you have a getNext method, for example, doesn't matter how you do it underneath, you can change it, you can do whatever you want as long as it works and as long as it's clearly defined. So another simple example, if list had an array size method, this would mean you'd be stuck with only being able to build array-based lists, right? If the list interface had something that was, so specific and like niche for an array size only, this limits everything now that implements the list interface. And so a Java interface has both a formal and informal part. The formal is the list of method signatures, right? The actual code that's in the interface. But the informal is the rules for using the interface that are not enforced by the compiler. This is how the software engineer actually ends up using the interface. So for example, if your code requires methods to be called in a particular order to work properly, that's an informal part of the interface. The compiler is not able to catch, oh, you have to call this before this. But if you as the programmer, design your code such that has to work like that, then it's an informal or sort of implicit part of your interface. If your add method throws an exception on null inputs, that's an informal part of the interface, right? Because now you have to work with this exception and do the error handling like we talked about earlier. Another example, the runtime for a specific method is sort of an informal part of the interface. And so someone who's working with your interface is going to, consider the runtime, and that's not written into the code. The compiler doesn't say, by the way, this is constant time, but it's part of it. It can only be specified in comments, It's not something that you can convey otherwise. It's something the programmer has to find by looking. Be wary of any informal rules in your modules as you build projects 2 and 3, because these informal rules It's easy to forget them. It's hard to convey them. And they are, a real area where you can introduce bugs to your code. We also have this quote from Alistair Hout: the best modules are those that provide powerful functionality yet have simple interfaces. I use the term deep to describe such modules. And so you can almost think about it if it's like what the user sees is the surface, and maybe it's a small area, it's this simple little interface, but underneath it's this deep like well. And so rather than having the person at the surface have to see this huge area and look at the whole thing or with all this complexity, they only have to look at this small area from above, but underneath it might be deep. And so the most important way to make your modules deep is to practice information hiding. In other words, embed knowledge and design decision in the module itself without exposing them to the outside world. Again, it's abstraction. It reduces complexity in two ways. It simplifies the interface, and it makes it easier to modify the system. The opposite of information hiding is information leakage, and this occurs when a design decision is reflected in multiple modules. Any change to one requires a change to all. And so information is embodied in two places. In other words, it has leaked out from the one place where it should be. And so from Alistair Hout, information leakage is one of the most important red flags in software design. One of the best skills you can learn as a software designer is high level of sensitivity to information leakage. And so in summary, and some suggestions for project 2 and 3 and any other large scale projects, build classes that provide functionality needed in many places in your code. And so again, this is sort of the idea of building a module that other places can use without having to know what's going on in the module. Create deep modules, so classes with simple interfaces that do complicated things underneath the surface. Be strategic, not tactical, right? Go in with a plan and think deeply about your plan. Think about all the options before you choose one. And hide information from yourself when it's unneeded. Another thing, hydration is key. If you are assigned female at birth, you should drink 11 cups a day. Assigned male at birth, drink 16 cups a day. And that's another important part of being a software engineer, is to be hydrated. You're probably not drinking enough water.